Hey guys, welcome back. We are taking a look this time at moving into area and perimeter, some geometry stuff here, and a couple of formulas to deal with, but nothing too major. We broke this into two parts. The first one, we're just going to kind of explain the formulas and how we came up with them, and the second part that you'll see a little later is we're going to take these formulas and put them to use. So let's check out practical problems with area and perimeter. Now, hopefully you guys remember from fifth grade, fourth grade, third grade, the difference between area and perimeter. Perimeter, that's going to be the outside, going around the outside of a figure. It doesn't matter if it's a square or a rectangle or a triangle or a trapezoid or a pentagon or a hexagon or a dodecagon. When we measure around the outside of that polygon, that's the perimeter. On the other hand, we have area. So here's the same rectangle, but instead of going around the outside, area is going to talk about what we have in the inside, filling up the inside. And one thing about area that makes it a lot different from perimeter. Perimeter, if we're measuring in inches, it's just inches. If I say, what is the perimeter of the yard? We measure it in feet, and that's it. But area is a little different. When we measure the inside, we're trying to figure out how many square units can fit inside of that shape. So we are going to say feet squared or square feet or square miles or square inches. For perimeter, it would just be miles or inches. But for area, we have to use the squarea. Remember me saying that before? Kind of a goofy thing, but it helps us remember. Let's start with the easier of the two. Let's talk about perimeter. When we're dealing with perimeter, we're going around the outside of that figure. So here we've got a swimming pool. We're going to put a fence up around that swimming area. Remember, when we're trying to find perimeter, we have to add up all the sides. So we've got to get some measurements. This is a 10 by 5 rectangle, 10 feet long and 5 feet wide. Now, let's not make the mistake of just saying, oh, well, 10 plus 5, the perimeter is 15. That is a very easy mistake to make. Don't make it. When we add up all the sides, we've got to remember, hey, there are more than just those two sides. We've got a side here and a side here we haven't even talked about yet. So lucky for us, we know that whatever the length of the top is, that's also the length of the bottom, and the left is equal to the right. So if the 10 is the length of the top, we know the bottom is 10, the left is 5, the right is 5. Now we know all the sides, and we're just simply going to add them up. 10 plus 5 plus 5, and you don't even have to add them in this order. That's that commutative property. We add them all up, and we get 30 feet. And we want to make sure we circle our answers. That's perimeter. That's how easy it is. So now we're going to move on to area. Area, again, not too difficult when we're dealing with rectangles and squares. Here I use this picture of a soccer field because the green grass would be a good representation of the area. And the way they have it mowed, it looks like it's in a grid pattern, which is perfect for what we're trying to do. So when we're dealing with area, let's say we have that exact same rectangle we used before for perimeter. And our measurements were 10 by 5. It's 10 feet long, 5 feet wide. When we're working with area, remember, we're trying to grid this figure. We're trying to put square units in there. How many square units can fit? Now, we could go ahead, and if we wanted to, we could go, well, that's 1, 2, 3, 4, 5, and count them. That would take forever. So luckily for us, we have a formula. We're going to use area equals length times width. Now, hopefully you remember that from 5th grade. Area of a rectangle or a square is length times the width. So, like we did with our circles, if we have a formula, we're going to plug in our ingredients. It's kind of like a math recipe. And we know our length is 10 and our width is 5. And don't worry, if you flip those around and say, oh my gosh, I thought the width was 10 and the length was 5. It's okay. Because again, with that commutative property, 10 times 5 and 5 times 10 are going to give us the same result. We're going to multiply those and we're going to get 50. But remember, when we're dealing with area, we're trying to figure out how many square feet or inches or centimeters or miles fit inside of the figure. So we have 10 times 5, we get 50 square feet. And of course, we always circle our answer. Okay, so we've got this. The perimeter is around the outside. The area is the inside that we're filling up. So in this rectangle, the blue line would be the perimeter. The area would be the red. The only difference when we talk about our final units, perimeter just would get inches or feet or centimeters or miles or kilometers. But area is going to get, remember, we're trying to figure out how many square units fit inside that figure. But now we're going to take a look at triangles. What about triangles? In order to think about a triangle, I want to first go back to this rectangle idea. When we figured this out, we said that it had an area of 50 square feet. If you remember, it was 10 by 5. So we said this had an area, this rectangle had an area of 50 square feet. Now, what if I chop this in half? If I cut this in half, what would the area be of this part of the rectangle or this part of the rectangle? What would the area be for those two? If I split the rectangle in half, what would it be? Well, half of 50 is 25. So 25 square feet, 25 square feet. Makes sense, right? I hope. When I'm dealing with the rectangle, I could also cut it in half. Remember, we still have that 50 square feet. We could cut it in half horizontally. So now the top half is 25 square feet, because that's half of 50. And the bottom half would also be 25 square feet. Now the question is there another way we could split this rectangle in half? Well, sure. We've taken our 50 square feet, we've cut it vertically, and got 25 on each side. We've cut it horizontally and got 25 on top and bottom, I should say. But what about if we slice this 50 square feet diagonally? Did I still cut it in half? I sure did. We got 25 square feet in that top left, and the bottom right is another 25 square feet. Well, take a look at the shape you just created. Can you see it? There's our triangle. So all I did was I took the area of the rectangle and I chopped it in half. And it's still going to be that 25 square feet. I just colored it blue. So now, when we're dealing with a triangle, we have a couple of different terms that we use. We don't call it a length and a width. Instead, when we're dealing with the area of a triangle, we still have a 10-foot by 5-foot figure, but instead of length and width, we call it the base, and that's going to be the bottom part of our rectangle. So that's going to be this area right down here. Whatever it's sitting on, I like to say it sits on its base. And then the 5 is no longer just going to be the width, it's going to be called the height of the triangle. And that makes sense because we're trying to figure out, well, how far from top to bottom are we going, from its lowest point to its highest point? And that's telling us how tall that is. So the area of a triangle is dealing with the base and the height. Now this is the most complicated part of this part 1 here. When we're dealing with the area of a rectangle or square, we just do length times width. But as you can see, we don't have a length and a width for a triangle. We have a base and a height. Well, it's going to be very similar. We're going to take the area to find the area, we're going to take base times height. So in this case, it's going to be 10 times 5, and we're going to cut it in half. Can you see where that came from? From the rectangle. We took the length and the width of the rectangle and cut it in half, and that made a triangle. We're going to do the same thing, but instead of length and width, we're calling it base and height, and then we're going to cut it in half. And how do we cut something in half? Well, we just take it and we can divide it by 2. That's the easiest way to do it. So let's go ahead and get cracking here. Um, let's fill in our numbers, put our ingredients in. The base is 10, the height is 5, 50, that's what 10 times 5 is. And we're going to take 50 divided by 2, and I bet you already know what the answer is going to be. 25 square feet. So the area of this particular rectangle is 25 square feet. Oh, always remember, circle your answer. Okay, guys, so a couple things to remember. The area of a rectangle or square is we're going to take the length times the width. For the area of a triangle, we do not have length and width, but we do have the base, and the base is going to be the bottom, whatever that triangle is sitting on. Usually it will be identified. You won't have any trouble figuring out where the base is. And we need the height. And in a right triangle, it's pretty easy to see. It's just from the bottom to the top, from the base up to the tallest point. But when we have an equiangular triangle like the one on the right, a lot of times, don't get tricked, they will put a dashed line right down the middle, and that is going to be our height. So no matter where you see it, we're going to take the base times the height, and then we're going to divide it by 2. That's the end of the first part. Part 2 is going to be using these formulas as we try to figure out some real life situations.